A very good morning to Venkatesh Shivakrishna sir, myself Iqra Fathima from CSE A section bearing roll number 234G1 A0561. Today's my topic in CAA2 assignment is Principle and Applications of Gas Chromatography from Chemistry. Gas chromatography contains introduction, types, principle, diagram, working, instrumentation, applications and conclusion. Introduction. Gas chromatography. It is a process of separating components from the given drug by using a gaseous mobile phase. It involves a sample being vaporized and injected onto the head of the chromatographic column. The sample is transported through the column by the flow of insert gaseous mobile phase. The column itself contains a liquid stationary phase which is adsorbed onto the surface of an insert solid. Two major types. So first one is gas solid chromatography and second one is gas liquid chromatography. So what is gas solid chromatography means? Here the mobile phase is a gas while the stationary phase is a solid used for the separation of low molecular gases. Example: air components H2S, CS2, CO2, rare gases CO and oxidized of nitrogen. So next, gas liquid chromatography. The mobile phase is a gas while the stationary phase is a liquid retained on the surface as an inert solid by adsorption or chemical bonding. And next one, principles. The principle of separation in gas chromatography is partition. The mixture of component to be separated is converted to vapor and mixed with gaseous mobile phase. The components which is more soluble in stationary phase travel slower and elute later. The component which is less soluble in stationary phase travels faster and elute out first. No two components have same partition coefficient condition. So the components are separated according to the partition coefficient. Partition coefficient is a ratio of solubility of substance distributed between two immiscible liquid at a constant temperature. And this is gas chromatography diagram main components. So first of all, gas flow controller, injection port and carrier gas supply, sample, detector, column and oven. This is data system, analyst. So next one is working. How to work gas chromatography? First of all, we have to fill the syringe with sample. Record the setting, that is column temperature, detector temperature and injection port temperature. Introduce sample into the injection port by completely inserting the needle into the rubber spectrum. Note down the injection time. The sample gets vaporized due to the higher temperature of injection port and is swept into column by carrier gas. These sample components now get distributed between the gas and stationary liquid phase, depending upon their solubilizing tendencies. The components with minimum solubility move faster and those with maximum solubility travel slowly. The components leaving the column activate detector and recorded to given a plot. And next one, instrumentation, carrier gas and He means helium, that is common in N2 means nitrogen, H2 hydrogen and argon. And next one is sample injection port, macro syringe, columns, detectors, thermal conductivity which is TCD and electron capture detector which is ECD and flame annihilation detector which is FID and last one is flame photometric which is FPD. And next one is applications. So applications are gas chromatography is used in qualitative analysis, checking of the purity of the compound. The percentage of impurities may also be calculated from gas chromatography. Multi-component analysis or determination of mixture of drugs. Isolation and identification of drugs or metabolites in urine, plasma, serum, etc. can be carried out. Isolation and identification of mixture of components like amino acids, plant extracts, volatile oils, etc. In some of the pharmaceutical applications. And last one is conclusion. So what is conclusion of gas chromatography? So gas chromatography, which is known as GC, is an analytical technique used to separate the chemical components of a sample mixture and then detect them to determine the presence or absence and how much is present. And thank you.